I know you guys just love radicals, and so we're going to talk about our last operation with radicals, adding and subtracting. Now when we add or subtract radicals, they must be similar, meaning the radicals must be similar. So think of it like terms. You can only combine terms with the exact same variable. You can only combine radicals with the exact same radical. So here we have 3 square root of 2 plus 5 square root of 2. These can be combined because they have the same radical, square root of 2. Now, sometimes you may need to simplify first. 12 square root of 12 plus 2 square root of 3 actually have the same radical. Both of them will simplify into the square root of 3. 12 is 2 square root of 3. So these are actually the exact same radicals. So sometimes you may have to simplify before you can add or subtract. And sometimes radicals can't be added or subtracted. The square root of 8 and the square root of 75 do not have common radicals even when simplified. So they won't be able to be added or subtracted. So you're going to have to make judgments based on the information. Do they have like radicals, or can I simplify them to be like radicals in order to add or subtract? If I can't, then they can't be combined. And as I said before, adding and subtracting radicals is similar to combining like terms. You only add or subtract like radicals. So for these examples, square root of 15 or square root of 6x, you can see in both of them. So I only add or subtract ones that are like. I can't do ones that are unlike. And I only combine the term in front of the radicals. So again, let's look at our first example. 3 square root of 15 plus 7 square root of 15. I'm only going to combine the numbers in front, 3 and 7, and keep the radical. So I get 10 square root of 15. Again, think of it like combining like terms. If I had 3x plus 7x, you'd tell me it's 10x, not 10x squared. So it's the same idea as combining like terms. Again, subtraction is the exact same thing. 5 square root 6x minus 11 square root 6x. We only combine the 5 and the 11. So 5 minus 11 is negative 6 square root 6x. The radicals stay. We combine the terms outside the radicals. So let's look at a couple examples here. We have 8 square root of 17 plus 12 square root of 17. These have common radicals, so they can be combined. So we're going to add the two numbers in front, 8 plus 12, and keep the radical, square root of 17, and add them together and we get 20 square root 17. Subtraction is exactly the same. First, we have to figure out like radicals. So both of them have square root of 3, so we know we can combine them. So 12 minus 7 gives me 5 square root of 3. Now let's look at this last example. We have two different sets of radicals. We have the square root of 7y and the square root of 5a. We can't put those together, but we can put like terms together. Again, think of it as y and a. If I had 14y and 2a, I couldn't combine them. But I can combine both of the ones that have a's and both of the ones that have y's. So if we look at our example, in blue, you can see the two terms that are like, both with 7y in the square root. And in pink, you can see the other two terms that are like, negative 2 square root 5a and 11 square root 5a. So we're going to combine only the like terms. 14 minus 3 square root 7y and negative 2 plus 11 square root 5y. And so we get 11 square root of 7y plus 9 square root of 5y. Again, just like combining like terms, which I know you guys are good at. Remember though, I said sometimes you have to simplify before you add or subtract. So now we've been doing ones that automatically you can add or subtract because they have like radicals. But sometimes we get things like this where 12 square root of 2 and 6 square root of 8, well, they don't look like radicals, but they're trying to be a little tricky. Because 6 square root of 8 actually simplifies to 6 times 2 square root of 2. Square root of 8, we can pull out a 2. We can simplify it, which means that 6 square root of 8 is actually the same as 12 square root of 2. And because of that, we can now add 12 square root of 2 plus 6 square root of 8 because they're both square root of 2's. 12 square root of 2 plus 12 square root of 2. Add the numbers in front. 12 plus 12 is 24 square root of 2. So sometimes you have to do a little work before you add or subtract. It's your turn now. Pause the video and try these 4 examples. First one, we're going to just add the numbers in front. 16 plus 20 is 36, square root 11. Second one also already has like variables, so we're just going to subtract the terms in front. 18 minus 14 gives me 4 square root 13m. The third one, we're looking for like ones, and we do have a set of like ones, square root of 3x and square root of 3x. So those two are going to combine, 15 plus 7, square root 3x, and then the negative 12 square root 5b, that's not going to simplify to 3x. So that one's going to have to stay on its own, just like you would with like terms. So we end up with 22 square root of 3x, because 15 and 7 is 22, minus 12 square root 5b, and that's the best we can do. It won't get any smaller because we don't have like radicals. Now the last one, square root of 27 minus 3 square root of 12, well, they're not like radicals, but remember we can simplify first. So if we look at these two that are simplified, we get 20 square root of 27 simplifies to 3 square root of 3. And if you don't remember that, take a second, pause the video, and try and simplify it. The square root, or negative 3 square root of 12, also simplifies to 2 square root of 3 times the negative 3. So it's negative 6 square root of 3. And now, when we look at these, they both have square root of 3. We have 3 square root of 3 is the same as square root of 27. Negative 6 square root of 3 is the same as negative 3 square root of 12. And so now we can combine the coefficients. 3 minus 6 gives me negative 3 square root of 3. Hopefully you got those all right. And if you don't, please bring in questions to class. Well, you finished all our operations with radicals. Great job, and we will practice this more in class.